Hello, today we're going to be talking about describing and conversing energy. This is going to be found in chapters 4, section 2, and section 3. So the first thing I want to talk about is that change requires energy. For example, if you don't like an app on your phone, what do? Well, some people would say they delete it, other ones say they change it. There's different things. So which of those changes required energy? Well, the simple fact that you had to like move your finger over the phone, that required you to spend some energy to do that, to delete the app. And it actually cost the phone some energy because you were doing work inside of the phone. It was moving some stuff digitally and deleting it and removing it from the file, which is why your battery would run down after a period of time. So all those types of changes require energy. What is energy? Energy is the ability to cause change or to do work. So whenever we do any of those things, energy is required to make that happen. Work transfers energy. So the energy that I have in me, right, and I do work, I'm transferring the energy from me into that object to do the work. We're transferring energy from one thing to another. And there are other different types of energy in the way we transfer them, but that is all a measurement of work. An example would be think of swinging a bat at a ball. You're working, you're transferring your energy right into that bat. You're going to change your chemical energy into physical or kinetic energy by swinging the bat, which is then going to make contact, hopefully, with the ball. All right. In physics, we use the term system, and we use system to define a place or that work takes place or where energy is transformed. And a lot of times we try to confine it into as small place as possible. That way we can kind of keep track of all of the energy and all the transformations. And one of the things that we'll talk about is like the conservation of energy in a system and things of that nature. And we've used the term before, but we really wanted to like place a definition on it. And the definition, or a good definition for it is a single object or a group of objects. A system is where we take an experiment or a system where energy is transferred. Think of, for instance, a car. Inside the car, I'll move my picture here. Inside of a car, there are actually many different systems. You could call the engine itself as a system. In one part of the engine, in one cylinder, that could be a system. Or we could look at all the different systems that take place in the car, which is then one system with all the many different things inside of it. And so we can see how we can break that apart and change little different things depending on what we're focusing on. And typically, the more precise the measurement, the more focused you are on the particular system or group of systems. So there are different forms of energy. What do I mean by different forms of energy? Well, the first one we talk about is radiant energy. This is the basic energy that all the universe, energy in the universe comes from, is the radiant energy. It's energy that radiates from one object to another. Think of the sun. All the energy on the earth has come from the sun. In of itself, we all require the sun for any of the energy we get. How does that work? Well, plants use photosynthesis. They take the energy from the sun, convert it into chemical energy, and then we eat that chemical energy to gain our energy. Animals that did that long ago died, fossilized, became oil. We burn that for fuel. So that all kind of comes from radiant energy. The next energy we talk about is kinetic energy. We know this is energy due to motion. The really cool thing about physics is we actually have a formula for everything. And we can measure how much kinetic energy an object has due to its velocity, due to the fact that it is moving. And that formula is right here. It's Ke equals 1 half mv squared. So we just square the speed, square the velocity, and we take 1 half times the mass. And that gives us our kinetic energy in joules. So this gives us a measurement of joules, which is, if you'll notice, that is kilograms and meters per second squared. Okay. For instance, if we had this example here, I got a skateboard rider, and he is 2 kilograms, and the speed he is traveling at is 5 meters per second. We could actually tell how much energy he has if we do our formula, 1 half m. Well, that's 1 kilogram because his mass is 2, so it goes to 1. And his velocity is squared, which is 5 times 5 is 25. So 25 times 1 is 25. So he has he has 25 joules of kinetic energy as he's moving. All right, so that's kinetic energy. Now let's talk about potential energy. We've talked about kinetic and potential energy before. We did with the roller coasters and different things like that. But now we're really kind of nailing down the definitions and actually providing a formula with them. we're taking that concept and we're kind of going further with it. Potential energy is energy that's stored due to interactions between the objects. And the most common one is gravitational potential energy. I'm holding up something in the air. Gravity wants to pull everything down, so there is potential energy stored in this simply because of its height, the position that it's stored at. Okay? We also have elastic potential energy. This is by stretching or compressing an object or a spring. We also have chemical potential energy. This is due to chemical bonds. It's the type of energy that we gain by eating our food. Okay? And those are released during a reaction. So you can store chemical potential energy for a very long time, and then it takes a reaction to release that energy. And as I've already talked about gravitational potential energy, this is due to the gravitational forces between objects. Our formula for gravitational potential energy is right here. Potential energy is mass times the gravity, which is newtons per kilogram, and multiply that times the height, so mgh. Right? Gravity is multiplied by mass, acceleration of gravity, and the height of it. Law of conservation of energy. We mentioned this before when we were dealing with a roller coaster, and that the conservation means it's saved, which means energy cannot be created or destroyed. It's always there. The only thing that can be is converted from one form to another. We can take gravitational potential energy, we can convert it to kinetic energy. We can take that kinetic energy and convert it into heat energy with friction, things of that nature. And energy also can only be transferred from one place to another. It doesn't just appear, right? And so the energy has to come from somewhere, somehow, someplace. And most of the time when we're dealing with the law of conservation, we split that system, the energy, split in that system between potential energy and kinetic energy. Again, think of the roller coaster. When we had a roller coaster, you trading kinetic energy for height to get potential energy, and then once you're up in the air, you now have potential energy, and you trade that kinetic energy as you go down. So roller coasters are great examples of that conservation of energy between kinetic and potential. Next, we want to talk about energy transformation. What do we mean? Energy is transformed or changed all the time around us. For instance, sun's radiant energy arrives at the Earth. That's converted sometimes to thermal energy, which keeps us warm. We take chemical energy and use a reaction, and we basically move the car. It goes from chemical to thermal. That's how the expansion properties work inside the internal combustion engine, and it provides motion. So we go from chemical to thermal to kinetic energy in a car. Mechanical energy is the sum of all of your kinetic and potential energy of the objects in the system. So we kind of add everything up, all of the kinetic and the potential, and that gives us the mechanical energy possible. Now, this does not include thermal, nuclear, or chemical potential energy. This is just the mechanics, the things that can move. Kinetic and potential is mechanical energy. So be sure you keep that straight on your quiz. We can use falling objects because we know they're transitioning from potential to kinetic as they fall. We can also look at this as projectile motion because we do have motion already as it's a projectile, and then we also know gravity is going to pull that back down, so we're going to trade that kinetic and potential energy as well. So for instance, if we look at the baseball player here in projectile, he has very high kinetic energy, low gravitational potential energy because he's low to the ground. As the ball travels high through the air at the top of the arc, it's low in kinetic energy because it's at the top of the peak, and it's high in gravitational potential energy. And then as gravity pulls it back down, it converts that from gravitational potential energy back into kinetic energy. All right, swing sets work on the same concept. You trade your kinetic energy, your motion to get higher on the back or forward swing, and then back and forth. It's constantly transitioning back and forth the swing. There are other energy transformations we want to kind of talk about. So why does a swing stop swinging when no one pushes it? Well, the answer obviously is friction, okay? And so there are other forms of energy that can affect the mechanical energy. So again, mechanical energy only deals with potential and kinetic energy. But yet the other forms of energy are affecting that mechanical energy, and the main one that we deal with on daily is friction. Also, we have air resistance. Any object that moves through the air encounters air resistance. And what they do is they transform mechanical energy into heat or thermal energy. So it takes away some of that energy, which is why a roller coaster won't run forever, or a swing won't swing forever. Even you take put it in a vacuum, There's less air resistance, so it will run longer, but the problem is you still have a little bit of friction, and that's going to slow down because it's going to take away your gravitational potential energy as well as your kinetic energy. And then lastly, we also have electrical energy because we transform that into thermal, radiant, or light energy, and sound energy. Think about your phone. You store up electrical energy in your phone in the battery, and it gets transmitted via light. The battery warms up. There's some heat loss as the circuits work inside your phone, and also sound. If you turn the sound on or listen to some sound, that will drain your battery even faster. Um, Continue on with some more. We also have chemical potential energy. This is like, say, fuel for your car or even your body. We take chemicals, right? We put a reaction into them. And again, I talked before where a chemical gets converted to thermal, to heat energy, which then gets converted to mechanical energy to propel your car. All plants transform radiant energy into chemical potential energy. That's where it all comes from. And then our body converts that chemical energy to heat, mechanical or motion, and then also sound. When you talk, you're converting your chemical energy into sound energy. So yes, talking all day is tiring. So how do we measure the output of energy? Well, we use the term called power. Power is the rate at which energy is converted. And of course, like all things in physics, we have a formula for power. And power, the unit we use is watts. We take our energy in joules and we divide that by the time that it takes for that to happen. So power is energy divided by time. All right, and that is our lecture for today. Thanks for watching.